Hai, Assalamualaikum and very good morning. I've been to my supervisor, Dr. Ajak Ogboo Chikere, my internal examiner, Prof. Dr. Hussain, Kayiem. Today, I would like to present the proposal defense for my FIP entitled Simulation of Integrated Fresnel and this Concentrator for High Temperature Generation in Hydrogen Production. Before I start my presentation, I would like to introduce myself. My name is Muhammad Shamuddin. My ID number is 19000009. I'm currently in final year second semester. The outline for this proposal defense, first is background study, then problem statement, then objective, scope of study, literature review, methodology, and lastly, expected outcome. Background study. More than 70% of the Earth is covered with water and 11.2% of the water is hydrogen. Therefore, the water is very abundant source of hydrogen. The advantage of being used of hydrogen as a fuel is that the water forms when hydrogen burns by combining with oxygen in the air. This means that the hydrogen is completely renewable. That is, when hydrogen is taken from the water, the least water is returned by occurring again as the result of the combustion. There are four main sources of the commercial production currently happen in this world. First is natural gas, then is oil, coal, and electrolysis. So the most dominant source are fossil fuels. Hydrogen as one of the few choices for storing electricity over days, weeks, or months can also help with the integration of the fluctuating renewables into the electricity system. There are three colors that we can categorize the hydrogen. First is gray hydrogen. The main source are coal, natural gas, biomethane. The byproduct are CO2. Next is blue hydrogen. The main source are natural gas, biomethane, biomass. The byproduct was captured, which are CO2. Last one is green hydrogen. The main source are water by using electrolysis process. The byproduct was very useful gas, which is oxygen. By using solar energy, green hydrogen has limitation due to its operation time, which is we can only operate the production during daytime, and it's weather dependent. Therefore, the conventional method, such as gray hydrogen and blue hydrogen, is still reliable compared using renewable energy. Potential for green hydrogen production. The demand of hydrogen as fuel is higher in the future globally. Hydrogen production by using renewable energies reduce the greenhouse gas effect. Malaysia is a country with suitable climate for solar water heating systems and solar electricity generation. It has a high solar energy radiation potential, with the average amount of daily sunshine ranging from 6 to 8 hours in areas with low cloud coverage and that receive large amount of solar energy. Because of green hydrogen production by using renewable energy is around 2.5 to 6 USD per kilogram, which has made it less competitive compared to gray and blue hydrogen. The green hydrogen production using concentrated solar collectors may have drawback due to poor supply of solar radiation, which is thermal energy. The objective is to determine the best configuration for fixed concentrated solar collectors in Malaysia setting for optimal energy transfer by assessing the effect of the hydrogen production in the electrolyzer. Scope of study, dimensions of the solar concentrators and polymer electrolyte membrane (PEM) electrolyzer are predetermined. the flow rate of the working fluid, which is water in the observer tube, is controlled. The system can be simulated by using CFD software such as ANSYS Fluent so that the hydrogen production can be optimized. The literature review for this project, I did some findings on water electrolysis, linear Fresnel reflectors, this concentrator, and PEM electrolyzer. So the relevance from the journal that now I know about the water electrolysis. Then the water electrolysis itself need high temperature. Then linear Fresnel reflectors. Linear Fresnel reflectors can reach high temperature up to 250 degrees Celsius. Next, for this concentrator, it can reach high temperature up to 2000 degrees Celsius. And lastly, about PEM electrolyzer, PEM electrolyzer can convert water into oxygen and hydrogen. The methodology for this project are project workflow, Gantt chart, block diagram, CAD modeling for the main components, configuration, and simulation. After getting the title, we need to identify the problem. Then I identify the components used in the system. Then I did some research on the solar concentrators and PEM electrolyzer. Then next, after proposal defense, I need to design the components based on the suitable dimension, then build up the system model, then conduct simulation on the system model using CFD software, then do this data collection and analysis. So after that, I will check if either the result can be accepted or no. If the result cannot be acceptable, so I need to do some modification. And lastly, I need to do the discussion, conclusion, and recommendation of the project. So this is the Gantt chart for FLP1. I have divided into two stages. First is data collection, then the second one is design. So there are several activities under the stages that I have mentioned before. So currently I'm in proposal defense. So before this, I did some identifying the problems, planning the project flow, literature review, progress assessment. So after proposal defense, I need to go for next activity, which is CAD modeling components, interim draft, report submission, progress assessment, and interim report submission. This is my block diagram for the system. So first, the water is being pumped to LFR, stands for linear Fresnel reflectors. Then after that, then it will flow to this concentrator. Then after this concentrator, it will flow to PEM electrolyzer. Then in PEM electrolyzer, there will be splitting. The water will split into hydrogen and oxygen. Just now I have shared about LFR, this concentrator, and PEM. So I will go to detail. So before that, this is the CAD modeling that I will refer to during my CAD design stage. So basically, linear Fresnel concentrator, or we can say reflectors, is one of the concentrated solar reflectors that is used to reflect by concentrating the thermal energy to the absorber tube. So basically we have the secondary reflectors above the absorber tube is used to maximize the amount of thermal energy to be absorbed. This concentrator, this is the CAD modeling that I will refer to. The parabolic dish concentrator, which is point focus solar collectors, is used to reflect by focusing thermal energy to the receiver mounted on the focal point in the front of the dish. This is the receiver. So All of these we call as dish. So the last main components is polymer electrolyte membrane PEM electrolyzer. The PEM electrolyzer is used to electrochemically split the water into hydrogen and oxygen at their respective electrodes, such as hydrogen at the cathode and oxygen at the anode. This is the best configuration that I have done by doing some literature reviewing. So, as we know, linear Fresnel reflectors, from my literature review, it can generate high temperature up to 250 degrees Celsius. For parabolic dish concentrator, can generate high temperature water temperature up to 2000 degrees Celsius. So basically, the water source, cold water source, will pump to the linear Fresnel reflectors. Then the output from the linear Fresnel reflectors will go to the receiver for the parabolic dish concentrator. Then it will go to PEM electrolyzer. Then it will split into hydrogen and oxygen. So the power supply for PEM electrolyzer and pump will use photovoltaic cell, which generate DC electricity, DC power supply. Lastly, simulation. CFD simulation software is used to analyze the productivity of the hydrogen in the PEM electrolyzer. The temperature produced by the concentrators also can be assessed in the simulation in order to get the required high temperature. So if we don't get the high temperature, so we need to change the flow rate of the water. The expected outcomes. The best configuration for this simulation model, where the water source is pumped first inside the LFR, then it will flow into this concentrator. This is because the project is aimed to get an optimal thermal energy, as thermal energy is higher in this concentrator compared to Fresnel reflectors. Thus, less thermal energy loss will occur. This integrated solar concentrators system will produce more hydrogen gas compared to one solar contractor system. So these are the references. I have like 9 references. 9 references. So that's all from me. Thank you.